Hello, algebra students. Mr. Lawrence here, and we are calculating slope today. Remember that earlier in class today we learned about the equation y equals mx plus b and how simple it was to graph. In fact, I'll bet you could tell me the equation of this line because you could figure out the slope and the y-intercept. Well, let's check it out. The y-intercept looks like it would be right here, and that would be the point 3, right? 0, 3. Okay, so b is going to be 3, and then the slope, if I could do my rise and run, from here I'll rise 1, 2, right? My rise would be 2, and my run would be 1, 2, 3. So it looks like my slope will be rise 2, run 3. So my equation would be y equals 2/3, sorry, let me rewrite that, 2/3 x plus 3, right? So we could go backwards. See how simple that is? Now, one peculiar thing here, which is actually kind of cool, is we know that this point, let's call it point A, has the coordinates 0, 3, right? I'll call that point A. This will be point B, and we're going to call it point C. What are the coordinates of point B? Well, let's see here. 1, 2, 3. And then the y would be 1, 2, 3, 4, 5. Okay. And the coordinates for point C are 1, 2, 3, 4, 5, 6, 6, and 1, 2, 3, 4, 5, 6, 7. That doesn't look right. It should be 8. Shouldn't it? Did I miscount here? Oh no, it is 7. Good. Sorry about that. Confused myself for a minute. Now, just a peculiar thing to notice here. If I add 6, 7, and I subtracted, say, 3, 5, I would end up with a 2 and a 3. Hey, look at that. That matches my slope, doesn't it? Yeah. What I'm telling you is that I can give you the slope of a line without ever having seen the line. All I have to do is subtract my y's, subtract my x's, and then the y's rise to the top. Because slope, as we know, is the rise over the run, correct? So I subtract my y's, I subtract my x's, and the y's rise to the top. So if I had 2 points, say the point 10, 6, and the point 8, 7, well, I know I've got an x and a y, and an x and a y, and if I subtract my y's, say I'll go 7 minus 6, and then I have to subtract my x's. Now I have to be careful. I chose to start with 7. I must start with 8. 8 minus 10. The slope of the line that would go through these 2 points would be 1 over negative 2, or better yet, negative 1/2. All I did was subtract my y's, subtract my x's, and my y's rise to the top. Let's try a couple more here. Hold on a second, let me pause the video. Okay, I'm going to run through these 4 examples. And again, all I do is subtract my y's. So let's see, I think on this one, I want to do 15 minus 12. And then I must do 3 minus 5. Why? Because I started with a 15, so I have to start with a 3. If I would have started with a 12, then I'd have to start with a 5. So it looks like the slope of this is going to be 3 over negative 2, or better yet, a negative 3/2. There's my slope. My rise number is 3, my run number is negative 2. Let's try this one. I'll tell you what, I'll start with the 4 this time. I'll do 4 minus 19. That's my slope, by the way. The y's rise to the top, and then I'll do 20 minus 5. That'll be negative 15 over positive 15, which is better said as negative 1. There you go. My slope is negative 1. If you want to keep it as a fraction, negative 1 over 1 would be the best answer. All right, here we go on this one. I think I'm going to start with the 7. I'm going to do 7 minus, what am I subtracting? -3. Don't just write 7 minus 3. That's a -3 there. Then I have to start with this -3, and I'll subtract 7. So this is my slope. 7 minus -3, minus a negative is plus a positive. I'll get 10. -3 minus 7, -10. The best answer will be -1. Now again, if you want to leave it as a fraction because we are doing slope, I will accept that. All right, number 4. I think I'm going to start with the -5. So I'll do -5 minus 2 over -6 minus -8. Those will change to positive. My numerator will be -7. My denominator will be +2. And there's my slope. All I'm doing is subtracting the x's and subtracting the y's. And I don't need to have a graph. Could use a graph, but I don't have to. That's the beautiful thing about this. Okay, now by the way, in case you're having trouble with the homework, I'm going to go off on a tangent here. And I'm just going to help with the homework a little bit. Let's say I had the problem y plus 3 equals -4x plus 10. Okay, I want to be in slope-intercept form. I remember I need the y to be alone. Is the y alone? No, of course not. There's a +3 there. So I'm going to subtract 3. But if I subtract it from the left-hand side, I have to subtract it from the right-hand side. And so my left-hand side becomes y equals -4x plus 7. So I have my y-intercept is the point 0.07. I have my slope as a fraction, -4 over 1. So I'm going to go up to 7, which I believe is right there. Nice big point. And then I'm going to clone him. And I'm going to go down 4, 1, 2, 3, 4, and run 1. And then I'm going to go down 1, 2, 3, 4, and run 1. I could go up 4 and 1, 1, but I kind of run off the graph. Sorry. I was kind of laughing at myself for saying 1 instead of run. And then I goofed up. So if I go down 1, 2, 3, 4 and run 1. All right. And of course that does need to be right. And there you go. There's my line. Okay, so hopefully that'll help you with the homework. You have to get y alone. Um, plot the y-intercept first, and then use your rise and run to get your other points. Now, of course, you only have to do 3 points, but if you did 4 for perfection or something like that, that's fine. All right, I really don't have much else. I think that's it. Mr. Lawrence signing off. Have a good night, everybody.